Okay, thank you very much, Macarena. Let me just say morning to everyone, and thank you for participating in today's webinar. And as usual, we always say, that we know that your time is precious, and you could have, spent that time doing other just as important things, but you chose rather to spend the time with us. So on behalf of Mr. Hector Negron, our Managing Director, I just want to say thank you very much. And as we begin, I'm just going to share my screen. And after I share my screen, I'm just going to ask you just to quickly confirm, if someone can confirm if you're actually seeing my screen.
Yes, Steve, we can see your screen.
Beautiful. Now, as always, it's always good for me to always provide some context of our webinar presentations. And in providing the context, I always like to use this diagram to basically point out where we are. And as you look at the entire schema of JET Analytics and how JET Analytics operates, again, you may remember you have what is called the JET Data Manager. This is the first stage, as indicated here on the left-hand section of our screen, where we say the responsibility of the JET Data Manager is to, for example, one, ensure that you can connect to all the various types of data sources, as long as those data sources are what is called ODBC compliant, where ODBC is an acronym for Object Database and Connectivity, which is just really a protocol which facilitates the connecting of different types of databases. And whether you are using a CRM database or some kind of Microsoft SQL database, or one second from it, right? So, or some kind of Excel file or text file, as long as you can connect via ODBC, then you can use the JET Data Manager to connect accordingly. And also it is at the JET Data Manager that you actually do the first level of data cleansing. And so therefore you're able to determine what tables and what fields you want to bring in from your various data sources into your project. And as you move from the JET Data Manager, you then move now to what is called the staging section, the staging database. That's where you pull all your data from the various data sources and consolidate it now into one repository. And that's called the staging database. Now, as you bring all this data, there is the expectation that you'll be doing additional data cleansing on your data. For example, one of the examples I always like to use is the issue of dates. If I were to give you a date 1/2/2022, we know that you could say that's the year 2022, but is that the date, the 2nd of January, or is that the date 1st of February? Depending on which location or which localization you're actually presenting your data, there could be different interpretations for that date. So one of the things you want to make sure you're doing is when you're bringing over the data, your data therefore is consistent. So this is where you'll be doing additional data cleansing in the staging database module. And as you move from the staging database, you now move to the next level, which is the data warehousing. Here at the data warehousing level, you are actually still doing additional data cleansing, but now you're setting up your data so that you can now use them to build cubes, etc., and data marts. For those of you who are familiar with some of these terminologies, a data mart is simply a subset of an entire data warehouse data set. And as you now create your data marts, you can now move into the cubes. And the cubes are developed using the JET Analysis Service as well as it uses the Microsoft SQL analysis server. So it therefore means in your environment within your organization, you will not only have to install the Microsoft database engine, but you also would have to install the Microsoft analysis service. So this is where we are now, because here at the JET Analysis Services, our webinar today, we'll be looking at these cubes and what are the things we can do with these cubes, because it is in the creating of these cubes that you can now ensure that your data is now made available to your front-end application, the applications that the users actually use. For example, those who will use Power BI, those who probably might want to use JET Reports itself, or maybe any of the Office 365 products like Excel Online, or any of your third-party user interface tools that you're able to use to query your data. So what are we going to do today? As we're going to be looking at perspectives, there are a couple of things that I want us to look at. Now, if you're still able to see the screen, this environment should be familiar to you right now, because this is the JET Data Manager server. And as we started, we looked at, the first pane, which is called our Solution Explorer. And depending on which of the levels you'd like to drill down to, right, you can just simply double click and it opens the particular level for you to conduct additional analysis. So here at the JET OLAP, this is where we're able to now see the online analytical processing. And once you see anything making references to OLAP or online analytical processes, you know that we're talking about Microsoft SQL Server Analysis Services. And for this project, which is a standard project, which was created for JET, they actually created 6 cubes. So the cube, unlike a data warehouse, a cube is simply a smaller collection of data extracted from your overall database. And with the cube, you're able to add what is called dimensions, where the dimensions provide some perspective. For me, I've found that the best example to give when you're talking about cubes within the context of data warehousing is to just bring as an example, those who may remember the concept of the Rubik's Cube, right? Where you had the various patterns and you're able to move the cubes around, etc. The idea is that with the Rubik's Cube, or in this case, the JET Analytics cubes, you are therefore able to analyze your data from many different perspectives. So for instance, if you have sales for the month for $1 million, for example, you could just have one perspective, which is just the total sales. But what if you wanted to analyze those sales by, say, salesperson? Then you could look at how that $1 million sales for the month has been allocated to the various salespersons. So therefore, you're able to conduct an analysis of that $1 million from the perspective or from the dimension of the salesperson. However, you would want, through one click of a mouse, to be able to switch your perspective or switch your view, where you might want to see the analysis of that $1 million worth in sales, maybe from the perspective of a sales region. So therefore, you are now able to see for the Eastern region how much of that $1 million sales relates to the Eastern region versus the Western region, etc. Or it's very possible that you could so set your data results so that you're able to see it from a cross-sectional dimension, meaning you're able to see your data both from the perspective of the salespersons as well as the person in combination with the perspective of a sales region. So let's do some additional work here on our sales cube. So this is our sales cube, and under the sales cube, you're actually seeing 3 nodes. One which relates to measures, one relates to script commands, and the other which relates to dimensions. Now, just for review quickly, I'm just going to look again at the sales cube. So if I right click the sales cubes, and then this reveals what is called my context sensitive help menu. So in looking at my context sensitive help menu, I could select, for example, to edit the cube. And in editing the cube, what am I seeing here? You will note here for the sales cube, I have 1, 2, 3, 4, 5 tables which have been selected. And we're saying out of this entire list of tables which can be found in the data warehouse, I've only decided to use these 5 tables to develop my cube. So tables which have been selected to develop a cube, those tables are called fact tables. So within my data warehouse, which has all these tables that are listed, I'm here saying that in developing the sales cube, my sales cube consists of only 5 tables. So these 5 tables which are selected make up what is called the fact tables. So in my sales cube, I will only need to make reference to the inventory valuation table, the sales change transactions table, the sales commission transactions, sales financial transactions, as well as the sales transactions table. So therefore, all my measures and all my calculations, all my aggregated values will be coming from any or combination of these tables. So if I just close the window, I'm now looking at the measures node. So what does the measures node tell us? The measures nodes gives us an idea of the various aggregates or measures which have been calculated. Now, all measures have to be numeric by nature. So that's the important thing that you have to remember. It's numeric by nature. So all our measures, which therefore will be aggregates, and when we're talking about aggregates, we're talking about mathematical computations. So therefore, to sum values is an aggregate, the summation of values. To find the difference between 2 numeric values, that's an aggregate. The addition of 2 or more fields is also an aggregate. Average is another example of an aggregate. Standard deviation is an aggregate. Variance and all these other statistical measures. Multiplication is also an aggregate. So therefore, whenever you see the term measure within the context of data analysis and data warehousing, a measure simply is therefore some form of aggregation that would have been conducted on a field or a number of fields. And as we say, aggregation, we're therefore talking some kind of mathematical computation. So one thing to also note for these standard aggregates, which have been developed for you, is that if you should look at the aggregate, it puts in bracket the name of the tables to which the calculation would have been done. So for instance, there is a measure here called sales, and it's a standard measure, but it's been derived from the sales transactions table. So where did the sales transactions table come from? If we just simply go back to the sales table and to the sales cube rather and edit the cube, you'll realize sales transactions was one of the tables that was selected from our data warehouse to become a fact table. So all of these 5 tables are now usable in creating measures. So you'll notice for all of the measures that would have been created, what is shown in bracket is the actual data table from the fact tables that would have been selected to create the measures. All right. Next, this node, which is called dimensions. So what really is a dimension? A dimension is a data perspective. So these dimensions would have been selected and enjoined with our measures from our sales cube. So the salesperson dimension, for example, which was added to this dimensions level or node, is actually saying that we can perform some computation or some perspective, or we can do some analysis of the data, looking at it from the perspective of the salesperson. We could also do some analysis or conduct some analysis using the item as our dimension. So therefore, you're able to analyze your sales based on which items have been sold. There's also a perspective or a dimension which is called location. So let's give this a little more in-depth look. If I should right-click the salesperson dimension, and if I should look at dimension relations, what is the dimension relations all about? The dimensions relations option is the option that you use to join your dimension table to your fact table. So I can choose to create a relationship from the salesperson table to all my fact tables, or I could look at it or create my relationship to only any single table. So if I were to choose all fact tables, what are we seeing here? Let me just widen this so that you're able to see. Good. So here we have what is called the dimension level. And the salesperson table, let me bring this down a little, see if you can see some more. Good. You may remember the salesperson dimension. Good. The salesperson dimension uses a salesperson ID. And what I'm saying here, that because the salesperson ID is known as the key column, it is a salesperson ID that I'm using to join or to relate to the sales transactions or the sales financial transactions or the sales commissions transactions table. And I'm able to create that relationship between the salesperson dimension and these other fact tables using the salesperson ID. So if I were to click down, what I'm seeing here is therefore a list of all the fields that are in this specific fact table. And out of these fields, or from these fields in this particular fact table, which is a sales transaction table, I'm selecting the salesperson ID. It therefore means that between the sales transactions table as well as the salesperson dimension table, both of them are related by way of the salesperson ID in the salesperson table and the salesperson ID in the sales transaction table. That's important to know. So both these tables are related by way of a field, and both the fields in these two tables have the same name, salesperson ID. Good. Likewise, in the sales financial transactions, right, they're related by the salesperson ID and also the sales commission table. Now let's look closer at this. You'll notice that there is no relationship between the sales change transactions table and the salesperson table. And likewise, there is no relationship between the salesperson dimension table and the inventory valuation table. It therefore means that I'm not able to produce any reports on the inventory valuation if I need to look at those reports from the perspective of the salesperson. If I were ever to do that when running my cubes and presenting my report will be incorrect because there's no relationship between the salesperson or the salesperson table and the inventory valuation. Additionally, there is no relationship that was created between the dimension level salesperson table and the change transaction, the sales change transactions table. So if I were to create a measure or to use a measure that uses a sales change transactions table, my report would be incorrect because I would not be able to conduct an analysis of the sales change transactions using salesperson. I, however, can conduct analysis of measures on the sales transactions table, the sales financial transactions table, and the sales commission transactions table by using the salesperson dimension key or dimension table rather, because there's a relationship that has been set up between the three, and that relationship is a common field called the salesperson ID. So let's look a little further on this dimension, which is called salesperson ID, because this dimension is specific to this cube, good? The sales cube. So the obvious question now is, where did the salesperson dimension come from? Good? We know that the measures, for example, the measures are I'd use the word aggregations, are measures which would have been conducted against specific fields within these various tables listed in brackets. But the obvious question is, okay, how do I get more information on the salesperson, for example, as a dimension? And we do it this way. We're able to find out information on the dimension, the specific dimension that is assigned to a cube by analyzing the global dimensions. Here's this node called dimensions, which is the global dimensions. And if I should search through my list, so this is a list of all the dimensions which have been created. You'll notice that there's a dimension here called salesperson. So from the salesperson table, Good. We will see that 3 what is called dimension levels have been created. So let's analyze the salesperson dimension. So if I right click and I go to edit the dimension level, I now see the definition of the salesperson dimension level. So this diagram or this window is actually saying that the dimension level called salesperson is coming from a table, which is called by itself also salesperson. So it is from this list of tables. And from within the salesperson table, the key column from the salesperson table is a field called salesperson ID. So what have we just seen a while ago? Is that the key column comes from the list of fields within the salesperson table. And therefore that key column, which has been identified, is called the salesperson ID. So the salesperson ID is a field that is being used from the salesperson table. And here where we say the key table, we're simply saying that out of all the tables in our data warehouse, we are only selecting the salesperson table. So I hope that's clear to everyone. Now, this level or this area, which has the following checkboxes, one which says visible. So by you checking it visible, you're actually saying that this particular dimension level will be visible to the end user. And by you also checking hierarchy enabled, you're actually saying that this particular field can be used as part of an hierarchy, which we'll come to shortly. And we're saying here that in our layout, we want it to be by name. What does this mean? You do not want your dimension to be just listed by the key column, but you might want it to be listed by a name, a more friendly name. And we're saying here is that we, however, want our salesperson data to be listed using the salesperson field. Okay? So we're using the salesperson field as the means of displaying the data, or rather the salesperson table and the name field. Good? So that's what this is saying. So in our salesperson table, which is used as a dimension, you'll see here 3 nodes. This therefore means that 3 fields have been identified: the salesperson, the territory, and the inactive status. So we're saying that if we want to analyze our sales transaction data, and if we want to do a further analysis of our sales data using the salesperson, you can group or you can even further analyze your data using either the salesperson ID or maybe the territory of the salesperson. So you may find you in your organization, you may have 10 salespersons, but those 10 salespersons might belong to 4 territories. So whilst you're able to conduct an analysis on each of the individual 10 persons, by you switching your view to say, I want to analyze my sales using the territory to which the salespersons have do belong, then your $1 million, remember the examples of the $1 million sales, can now be analyzed by territory rather than by salesperson. And you're also, here's another field chosen, which is called inactive status. So therefore, this looks to be like a toggle, a Boolean field, which is really a true, false, yes, no, see whether the salesperson is active or not. But if you'll notice a salesperson dimension level, you will see to the left a little key. That key, therefore, represents what is called the key level. So we're saying out of all of these fields, it is the salesperson ID, which is the key field. In other words, that unique field which identifies each salesperson. Well, let's come back and look at the dimension level again. You'll notice that we have here hierarchy enabled with a checkbox beside it. If also I should go to the territory and edit the dimension level, it also has the checkbox hierarchy enabled. If I should go to the inactive status, right click and edit the dimension level, you'll notice here also we have hierarchy enabled. So what really is the hierarchy? Well, I've created for you here a hierarchy, which is called territory. Well, so let's edit this hierarchy. And what does editing of the hierarchy does? The editing of the hierarchy allows you to determine whether you can have sub-levels of your analysis of your data. So for instance, by me selecting these two dimension levels, salesperson and territory, I'm therefore saying that it's very possible for me in analyzing my data for my sales, I can look at it from the level of the territory, and then from within each territory, I can analyze it based on the salespersons that come from each territory. In other words, drill down, right? Grouping or drill down. So the hierarchy provides the ability for you to create the drilling down processes for your data. So here, as we said, with these two selected, that is a salesperson and territory, I'm saying here that I can drill down by territory, and then from within each territory, I can see the salespersons who are within each territory. And therefore, by drilling further, I'm able to conduct an analysis of all the sales for salespersons within territories. So really, that's what hierarchy does. Hierarchy allows us to create a drill down perspective of our data, right? That drill down perspective so that we can go by groups and subgroups and subgroups, and you're not limited to the amount of levels that you're able to go. So can we see all of this in action? And the answer is yes. You may remember from a previous webinar where I showed you that the Jet Analytics gives you the ability to basically browse your cube. It's almost like a preview button. It allows you to browse your data to see what it really will look like should you were to use a tool like Power BI or Excel or any of your other favorite user interface or front-facing tools. So it is always good to always browse your cubes at the Jet Data Manager level before you actually deploy it to your end users, because you would hate to deploy an application which has errors in it, and then people make strategic decisions based on faulty data. So let's look at this. How can I browse my data or browse my cube? Again, if I position my mouse over the sales cube, then I right-click the cube itself, which brings up the context-sensitive help menu. And if I should browse the listing of my context sensitive, you'll notice that there is an option here which says browse cube. And when you click browse cube, okay, I'm getting an error here. It might be because the cube needs to be deployed and execute. 1 minute, let me see what's happening here. Oops. All right, I'm getting an error here. This error might be due. 1 minute, let me look. It might be that the services, my services might be shut down. 1 second, let me look to see if my analysis services is shut down. Let's see, SQL. All right, so I'm just doing a bit of a quick troubleshooting here. So SQL Server is running. I'm just looking to see if analysis services, good, analysis services seems not to be running. So I'm having a little issue here. 1 moment. 3x, H, F1906. Right, that error is actually telling me that the services somehow shut down on me for a brief moment. Let me see if this will start. All right, just give me 1 minute. Just quickly, NRX 1906. 1 minute. And the service NRX-1906. Ouch. 1 minute. Let me just quickly let's get the service. It was working up to a few minutes ago. All right, let's see. That should be the issue. Right, so for some reason my SQL analysis services shut down. So let's see if we should be good. Let's see if I can browse the cube. There we go. So we're now good. So for some reason my analysis services had shut down. I'm not sure if it was for doing some updates or anything. So what did I do? I right click my sales cube and then I selected browse cube. So the browse cube gives me an environment which is similar to Excel. So from our sales cube, I will first go to the measures. Do you remember these 5 names? These were the fact tables which were selected. And I'm saying I'm going to the sales transactions table. And I'm going to look at one of the measures. And I believe the measure we were looking at is probably the sales figure. So if I were to select the sales figure and put it into measures, so you'll notice now I have here just one data, a blob of data. This is the accumulated data, the aggregated data of 2,249,851. But now that we have that measure, the next thing we have to look at is what perspective we would like to look at this measure. And the perspective or the dimension that we looked at was the salesperson. And you'll notice that here we see the by territory and an arrow beside it. And that's because the by territory was the hierarchy. These were the 3 dimension levels that we created, and we also created that hierarchy, where under the hierarchy, we can now analyze the data by territory and also by salesperson. So if I were to move, so let's use the by territory hierarchy. So if I were to move that hierarchy and place it under the rows, you'll notice now that we not only are seeing the 2.249851 in total sales, but we are now able to do analysis using the hierarchies. So at the first level, we're able to see the territories. So here we see Australia and New Zealand, 32,625, Illinois and Missouri, 262. So at our first level of the hierarchy, which was the territories, we're therefore seeing the split of the 2.2 million over the various territories. And within each territory, if I were now to click the arrow, I'm now able to see the list of all the salespersons. But it just so happens that Lynn Jensen is the only salesperson that is within these territories. And it's probably the same thing for this territory called Australia and New Zealand. You only have Ian Marsh. So if you had more than one salespersons who were assigned to Australia and New Zealand, then you'd have seen the breakdown even further. So Ian Marsh, John Doe, Mary Jane, etc. And you'd have seen the split. Good. So this is how you're able to create dimensions which provide a perspective. And within the context of each dimension, you can also create what is called dimension hierarchies, which provides for you to do drill down. And it is always good practice whenever you finish creating or modifying your cubes to always test your cubes before you actually deploy it. And you test your cubes by just simply right-clicking the cube, and which brings up the context-sensitive help. And then you browse along the list and you click Browse Cube, and you will see this cube browser that comes up where you're able to analyze your data. Let's see if we could do anything further, because let's see, let's see what if there's anything else that could be maybe location. I could probably, let's see, I could probably use items. I'm sure items is one of those tables by me, the item class. If I could put item classes in the column, good. So you'll see now that I'm now able to conduct further analysis of my data. Let me see if I can close this a little for you to see. Let's close up some of the work here. So what I was able to do from the row perspective, I used the hierarchy, which was by territory. And then for the column, I used another perspective, which is by item class. So you're seeing attractive cordless phones, component inventory items. So therefore, the item class now becomes my columnar data. So I'm able to do further analysis where I'm able to see, for example, for my retail phones, how much was the total sales of retail phones within Australia and New Zealand, as against how much was the retail phones in Indiana and Michigan. Good. So I'm able to do even further analysis because I was able to relate the dimensions to the various fact tables. And because I'm able to do that, I'm able to conduct further analysis, just like you would in a Rubik's Cube. So I'm therefore able to see my data from many different perspectives. Good. And that is how we apply and use dimensions against cubes. In this case, we use the sales cube. Well, I guess that's it for today. I'd really like to say thank you all for coming. We really appreciate you spending the time with us again. And remember, if you have any questions, please feel free to reach out to us. We'll be more than willing, the team here from Optimus, and we'll be more than willing to assist as best as possible, whether to get the resources internally to provide you with the answers, or wherever we need to go to get the answers. Our team is more than willing to assist you accordingly. So with that being said, again, I want to say thank you very much. And I now hand you over to Macarena. Macarena?